Good morning, students. Now in this class we knew the next exercise. In the exercise 6 important formula is there. So first you memorize the 6 formulas and then we do the problems. Suppose the integration is of the form. Okay, these 6 types. Integration of, there will be 2 types of question be asked, dx divided by or 1 divided. The 6 formulas are important regarding the next exercise. The first one, integrating of 1 divided by a square minus x square. The integrating of 1 divided by a square minus x square with respect to x. 1 by 2a log within a modulus a plus x divided by a minus x plus c. You must memorize the formula. Is a formula where a is a constant and x is a variable. So integrating of 1 divided by a square minus x square into dx is equal to 1 by 2a log within a modulus a plus x divided by a minus x is the first formula. And the second formula is reverse. A square minus x square. Here x square minus a square. So outside is same 1 by 2a. Log of same within a modulus. Here is a plus x, a minus x, interchange. X minus a divided by x plus a plus c. The result is also there in your textbook. I just write the result and also it is a formula. You must memorize this formula. So there is a relation between these two formulas. Here a square minus x square, reverse x square minus a square. So 1 by 2a is common. Log is also common. So within modulus, here a plus x divided by a minus x. Here x minus a divided by x plus c. Okay, the third one. Integrating of 1 divided by a square plus x square. Suppose it's not a square, just 1. We already see the formula. Integrating of 1 by 1 plus x square is nothing but tan inverse of x. Instead of 1, any more constant is lies, then whose formula is 1 by a tan inverse of x by a. Okay, actually it is a formula. Suppose instead of a square just 1 by 1 is 1. Tan inverse of x by 1 is also x. So actually it is a basic formula. So 1 by a square plus x square formula is 1 by a tan inverse of x by a. You see the fourth one. This formula is also we already see. Suppose except a, the value is suppose 1. The formula is just sine inverse of x. Integrating of 1 divided by square root of 1 minus x square is sine inverse of x. But instead of 1, here a. So the formula is sine inverse of x by a. Is the fourth formula. And there is a relation between these two formulas, 5 and 6. What is the difference? Just only one sign. Minus sign is the plus. So 1 divided by square root of x square minus a square is equal to log of within a modulus x plus the same term below. Square root of x square minus a square. The second one also. Integrating of 1 divided by square root of x square plus a square is equal to log of within a modulus x plus the same term. Square root of x square plus a square plus c. So you must memorize first of all these 6 formulas. What is the first formula? Integrating of 1 divided by a square minus x square into dx, whose formula is 1 by 2a within a log modulus a plus x divided by a minus x. What is the second formula? Integrating of 1 divided by x square minus a square into dx, whose formula is outside same 1 by 2a log of within a modulus x minus a divided by x plus a plus c. And the third one is we already see in tan inverse. Now we see again integrating of 1 divided by a square plus x square or x square plus a square also given. The formula is 1 by a tan inverse of x by a plus c. And the fourth formula, integrating of 1 divided by square root of a square minus x square into dx. The formula is just sine inverse of x by a plus c. Fifth one, integrating of 1 divided by within a square root x square minus a square within a square root, whose formula is log of within a modulus x plus square root of x square minus a square plus c. And the sixth one, integrating of 1 divided by square root of x square plus a square into dx is equal to log of within a modulus x plus square root of x square plus a square plus c. So we must memorize these 6 formulas. Now the problem all are involving regarding these 6 formulas. Okay, now this is sum in exercise 11.10. Find the integrals of the following. So sums is there to find whose integrals. 4 in 1, first subdivision and second subdivision is there. First we try the first one. This is the sum 1 divided by 4 minus x square. Now integrate the term 1 by 4 minus x square into dx. 1 divided by 4 minus x square into dx. Now it is of the form. The identification of the formula is very important. 1 divided by, we write 4 as 2 square, okay? 4 as 2 square minus x square into dx. Now you see it is exact of the form 1 divided by, where 2 is a constant. So a square minus x square, okay? So we write the formula, you know that. Integrating of 1 divided by a square minus x square into dx. Whose formula is? Start from a square minus x square. 1 by 2a log of, within a modulus, a square minus x square is the, so a plus x by a minus x plus c. Here, in place of a and place of x, which value is there? To compare to the given sum in the formula, in place of a, okay, in place of a, 2 is there. And in place of x, same x. So a value is 2 and x value is same x. In some more problem, except x, so many values is there. So in this problem, exactly the value of x is x and the value of a is 2. Now I substitute this value in the formula. 1 by 2 square minus x square into dx is equal to 1 divided by 2 of 2. 2. A value is also 2. Log, within a modulus, a plus x, the value of a is 2. So 2 plus x divided by 2 minus x plus c. So it's nothing but our given sum. The value of 2 square is 4 minus x square into dx is equal to 1 by 2 to the 4. Log of, within modulus, 2 plus x divided by 2 minus x plus c. So it is the answer of the first one. Now I say the second solution. Integration of 1 divided by 25 minus 4x square into dx. We put the integration symbol, we must write dx because we integrate full term with respect to x. You have any idea? Using the same formula of the first one. 25 and 4x square. Our formula fully, the whole square term is in 1. So how to write 25? We write 25 as 5 square. And how to write 4x square? We write 4 as 2 square. And x already, 1 square is there. So I write the given sum as 1 by 5 square minus 2x the whole square into dx, okay? 25 as 5 square. And we write 4x square as 2x the whole square. Okay. Now it is also the same form of 1 divided by a square minus x square. But in place of a, 5. In place of x, 2x. Important, in place of x is 2x. It is composite function. So we write the formula. Integrating of 1 divided by a square minus x square into dx. 1 by 2a. Log, within a modulus, a plus x by a minus x plus c. Comparing the formula to our given sum, here in place of a, 5. So a value is 5. And in place of x is 2x. In place of x, 2x is there. So it's a composite function. So now I have applied this formula. Integrating of 1 divided by a, 5 square minus x, in place of x is 2x into dx is equal to 1 by 2 of a value is 5. 1 by 2 of a value is 5. Log, within modulus, a plus x, the value of a is 5 plus x value is 2x divided by a minus x, 5 minus 2x. Okay. but it is not our required answer. One more term is there. Is a composite function. Instead of x here 2x. Except x, any more number is there, we must differentiate that value and we put the answer in denominator. Important. And we write a whole divided by 2x. The differentiating of 2x with respect to x is 2. For your understanding, I write 2 of 1. Let's see. How we get 2x here? 2 into 1. 2x is there. It's a composite function. Except x, any more value is there. You differentiate the term and we put the answer in denominator. Okay. So what is the final answer? It's nothing but our given sum, okay? Integrating of 1 by 25 minus 4x square into dx. 2 5s are 10. 1 by 10. And also one denominator. 2 1s are 2. So 2 5s are 10. This 2. These 2 2s are cancelled? No, it's not cancelled. Because in the denominator. And it is a whole divided by the denominator. So we must multiply the number. Okay. This 2 actually goes to the new denominator. 2 2s are 4. 4 5s are 20. So the answer is 1 by 20 log of modulus 5 plus 2x divided by 5 minus 2x plus c. So if the formula is very well known, then the sum is very easy. Now we see the third solution. 1 divided by 9x square minus 4. Now we find this integration. Integrating of 1 divided by 9x square minus 4 into dx. Now we integrate the term. 1 divided by, how to write a 9x square with the whole square? We write a 9 as 3 square and also 1x square. So we write 9x square as, okay, 3x the whole square. 3 square is 9x square. And how to write 4? I write 4 as 2 square. The value of 2 square is 4. Except x, any more value is there. It may be x plus 3 or 3x. So it's a composite function. First, using the basic formula and we differentiate the term with respect to x. We put the answer in denominator. It's important. Okay. Now it is on the form 1 divided by, first one variable is there. So we consider it is x. So x square. Minus 2 is a constant. So it is on the form x square minus a square. So I write the formula. Integrating of 1 divided by x square minus a square into dx. Remain the formula. 1 divided by 2a log in a modulus is x square minus a square. So the numerator is x minus a and the denominator is x plus a plus c. We comparing the sum to the formula. So in place of x, 3x, and in place of a, 2. Okay. In place of x, 3x. In place of a, 2. And also is important, x is not x, it is 3x. Okay. Now we use the values 1 divided by 3x the whole square minus 2 square into dx is equal to 1 by 2 of 2. Okay. 1 by 2. The value of a is also 2. Log modulus x minus a, 3x minus 2 divided by x plus a, 3x plus 2, but it is not the answer. We write whole divided by. Whole divided by is a composite function. In place of x, 3x. We differentiate that value, actually 3 of 1 plus c. So it is nothing but 1 divided by, we write a 3x the whole square as 9x square minus 2 square as 4 into dx is equal to 1 by 4. Okay, 1 by 2 is 4 log within modulus 3x minus 2 divided by 3x plus 2 whole divided by 3 plus c. Okay, 3 ones are 3. Now is a denominator. and again one denominator. So this 3 goes to that one, or this 4 goes to down. We multiply, we get 3 4s are 12. So the answer is 1 by 12. Okay, 1 by 3 4s are 12. Log of within modulus 3x minus 2 divided by 3x plus 2 plus c. Now we see the second one, in second first subdivision. The question is same. Integrate the following with respect to x, or find the integrals. Integration of 1 divided by 6x minus 7 minus x square into dx. Suppose in integration the denominator is a quadratic polynomial, then directly there is no formula. So what we do, sir? So just we add and separate coefficient of x by 2 the whole square. It is a working rule to find the integration of the denominator is a quadratic polynomial. You see, it is a quadratic polynomial. Start from square. So directly there is no formula. So the first step, add and separate coefficient of x by 2 the whole square. But x square is start from minus. So first we simplify the quadratic polynomial. So in this purpose I consider this quadratic polynomial 6x minus 7 minus x square is there. For our easy convenient, I will take outside the minus sign, because this x square contains minus, so I will take outside minus. So it become x square, and plus 6x become minus 6x, and minus 7 become plus 7. For our easy convenient, I will take outside minus, because coefficient of x square should come 1. Okay, so I will take outside minus. Next, x square minus 6x plus 7 is not a factorized sum. Suppose factorized sum means multiply 7 we get minus 6, but we need some 2 square. It may be x square minus a square or a square minus x square shape. So the next process is just we add and separate coefficient of x by 2 the whole square. X square term is there, so x square minus 6x term. Okay, what is the coefficient of x here? Actually minus 6 is the coefficient of x. What's that value by 2? We cancel, we get minus 3. So we add and separate coefficient of x by 2 the whole square. Minus 3 the whole square or 3 square, both are same. Okay, minus 3 the whole square or 3 square, both are same. So we don't consider the sign, just we add and separate coefficient of x by 2 the whole square number. So 6 by 2 is 3. So I add 3 square and separate 3 square. Important is not a minus 3 the whole square, a minus of 3 square. And already the number 7 is there, so plus 7. Now we come one formula shape. So in this process, in all integration, the denominator is suppose a quadratic polynomial, numerator is just a number 1 or any constant. The working rule is add and separate coefficient of x by 2 the whole square. What is the reason, sir? You see, the first 3 term is exact one formula shape. Now you see it is of the form a square minus 2ab plus b square. A square x square minus 2ab minus 2 of b value 3, 2 3 are 6, a value is x, plus b square is 3 square. So a square minus 2ab plus b square. So the formula of a square minus 2ab plus b square is a minus b the whole square. Here a value is x, minus b value is 3. We expand, we get these 3 terms. X minus 3 the whole square, expand, we get these 3 terms. Minus, okay, this how minus is outside. 3 square, the value of 3 square is 9. Plus already 7 is there. Minus 9 plus 7 is minus 2. Minus of x minus 3 the whole square minus 2. So now we simplify. After the simplification, we multiply the minus sign inside. So it get minus of x minus 3 the whole square. Minus and minus is plus. Therefore, 6x minus 7 minus x square is on the form. First I write the positive term, okay? 2 minus of x minus 3 the whole square. Now I write that value in the given integration. So integration of 1 divided by, actually it is our given sum, okay? 6x minus 7 minus x square. Now we converted the term as 2 minus of x minus 3 the whole square into dx. Now we come one formula shape. Actually quadratic polynomial is given. Now we converted the quadratic polynomial as this shape. And our formula shape, I do one more work. So it is our form. First one is the number 2. So we consider it is a constant. And second one, variable x is lies. So we consider it is x. So it is our form a square minus x square, but 2 is not a perfect square number. But make it square. How will we take? I will write 2 as root 2 the whole square. Okay? Root 2 the whole square is 2 minus of x minus 3 the whole square into dx. Okay? Now we see exact is of the form 1 divided by a square minus x square into dx. You remember the formula? 1 divided by, we know that integrating of 1 divided by a square minus x square into dx. The formula is 1 by 2a. Okay? 1 by 2a. Next. Log within a modulus is a plus x lies in numerator. And a minus x term lies in denominator. We compare the formula to our given sum. In place of a square. In place of a, root 2 is there. In place of x minus 3 is there. So here, a value is root 2 and x value is x minus 3. I apply this value 1 divided by root 2 the whole square minus of x square. The value of x is x minus 3 the whole square into dx is equal to 1 divided by 2. Okay, 2. A, the value of a is root 2. Log within modulus. A plus x, the value of a is root 2 plus x value is x minus 3 divided by a minus x, a value is root 2 minus of, okay, this minus of x value is x minus 3 plus c, it is also a composite function. In place of x here, x minus 3, and we differentiate the term x minus 3 with respect to x, we put the answer in denominator. Okay. What is the differentiating of x minus 3 with respect to x? X with respect to x is 1. And the differentiating of the constant 3 is 0. So I don't write 1. Suppose 2x minus 3 is whole divided by 2, we must write. Okay. 1 by 2 root 2. Okay. 2 into root is 2 root 2. Log root 2 minus 3 plus x. First I write the numbers. In denominator important, this minus is common in both the terms. Root 2 minus x minus into minus 3 is a plus 3. So integrating of 1 divided by root 2 the whole square minus of x minus 3 the whole square is nothing but our given sum. So we write 6x minus 7 minus x square into dx term is nothing but 1 by 2 root 2 log of root 2 minus 3 plus x. In denominator also, first I write the constant. You see which choice will leave as it is. But for our easy convenience, first I write the constant and variable. Denominator also, root 2 plus 3 minus x plus c. So suppose in the integration, the denominator is a quadratic polynomial What is the first work? To convert it in, it is a square minus x square form or x square minus a square form, because we have the formula of integration. It may be 1 divided by x square minus a square or a square minus x square. So in this purpose, what is the first step? To make the coefficient of x square is 1. And the second step is we add and subtract coefficient of x divided by 2 the whole square. Because we do this work, it is of the formula shape of either a minus b the whole square or a plus b the whole square. After that, one formula shape will there. Then using this formula we solve the problem. So in this sum is a square minus x square mod. In one more sum, suppose it is of the form x square minus a square also. So the quadratic polynomial given in denominator, what is our first work? To make the coefficient of x square become 1. And the second step, add and separate coefficient of x by 2 the whole square.